At the end of the topic, you will be able to explain the principle of a concave mirror, discuss the characteristics of the image formed by concave mirror, determine the focal length of concave mirror, list down the uses of concave mirror, describe the image formation by convex mirrors, explain the characteristics of image formed by convex mirrors, list down the uses of convex mirrors. We begin every day with light. We see many things around us. Light is a part of life to survive. We see shining objects, glittering objects, and brilliance of precious stones, and so on. Do you know the reason behind them? Yes, it is due to the reflection, refraction, and many more phenomena of light. Scientists had actually tried to explain the nature of light and its various phenomena. The reflection on a plane mirror follows two rules known as laws of reflection, and it deals with angles. To understand the angles, we need to imagine a single light ray striking a surface. This is the incident ray. The ray bouncing off the surface is the reflected ray. We can draw a perpendicular line for the surface of mirror at the point of incidence. Now, the law of reflection states that the incident ray, the reflected ray, and the normal at the point of incidence lie on the same plane. Further, it states that the angle of incidence is equal to the angle of reflection, where I is the angle of incidence and R the angle of reflection. We know plane mirror form images of size equal to size of objects and at the same distance from the mirror. If we need enlarged or diminished image, how do we get it? Yes, spherical mirrors can be used to produce enlarged or diminished images. A spherical mirror is a curved surface mirror that has the same shape of portion of large sphere. The mirror surface that is bulging outward is called a convex surface, and the inner curved surface is called the concave surface. How do you decide if a mirror is concave or convex? If the outer surface of the section reflects, then the mirror is convex mirror. However, if the inside surface reflects, then the mirror is concave. Convex mirror produces diminished image, whereas concave mirror produces both diminished and enlarged image. We will learn the concept of light ray in a concave mirror and characteristics of image formed by concave mirror in the following slide. Let us discuss the important terms associated with the concave mirror. Consider a concave mirror AB. The center of the concave mirror P is called as pole of the mirror. Using the curvature of the mirror, we can complete a circle. And PC, the radius of that circle, is called the radius of curvature. The center of the sphere C is the center of curvature. The straight line passing through P and C is the principal axis of the mirror. The laws of reflection holds good for all reflecting surfaces, either plane or curved. For instance, a parallel beam of light that is parallel to the principal axis incident on the concave mirror gets reflected. All the reflected rays either meet or appear to meet a point on the principal axis called the principal focus F of the mirror. The distance from the pole of the mirror to the principal focus is the focal length of the concave mirror. Draw a normal line OC from the point of reflection at the mirror to the center of curvature. The angle XOC is the incident angle. The angle COY is the reflected angle. Convex mirror also have the following terms used to describe the image formation as that of concave mirror. pole of mirror P, center of curvature C, radius of curvature R, principal axis OP, principal focus and focal length. Let us now see how images are formed in a concave mirror for objects at a larger distance. A parallel beam of light originating from a distant object like a lighthouse after reflection of the mirror meet at the focal plane to form the image. This image can be obtained on the screen and hence a real image. The image formed has several characteristics. The size of the image is lesser than the size of the object. Since the parallel beam of light exactly meet at a point, it forms a real image. The image formed on the screen is upside down, that is, an inverted image. The distance between the mirror and the screen gives the focal length of the concave mirror. Now, let us discuss the nature of the image formed due to the position of object. Look at the difference in the given images. According to these images, when a real object is placed between the center of curvature and the focus of the mirror, the object AB has its image A', B' formed beyond the center of curvature. This image is real, inverted and enlarged. On the contrary, when the object is placed between the pole and the focus, the object AB has its image A', B' formed behind the mirror and is virtual, erect and enlarged. The given table details the nature of images obtained for different positions of the object. Concave mirrors find various uses in day-to-day life. You can use concave mirrors to magnify the images formed on it. They are used as reflectors on the headlight of vehicles. Dentists and ENT specialists use concave mirrors to check inner parts of ear, throat and nose. They are used in satellite dishes to collect energy for TV sets. The concave shape of a bat's ear helps it to collect sound energy. They are also used in telescopes to view distant objects.
Convex mirror always forms a virtual, erect and a diminished image irrespective of the position of the object. The given table details the nature, size and position of the image for two different positions of the object.
Let's look at the uses of convex mirrors. As they produce virtual, upright, diminished images, convex mirrors are used in the rear view mirror of vehicles to get a view of the road behind the vehicles approaching to the right. They are also used as security mirrors in shops as it covers wider area than our naked eye. Similar to concave mirrors, convex mirrors are also used in telescopes.
While dealing with the reflection of light by spherical mirrors, we shall follow a set of sign conventions called the new Cartesian sign convention. In this convention, the pole P of the mirror is taken as the origin. The principal axis of the mirror is taken as the x-axis, x-x of the coordinate system. The conventions are as follows. The object is always placed to the left of the mirror. All distances parallel to the principal axis are measured from the pole of the mirror. All the distances measured to the right of the origin along plus x-axis are taken as positive, while those measured to the left of the origin along minus x-axis are taken as negative. Distances measured perpendicular to and above the principal axis along plus y-axis are taken as positive. Distances measured perpendicular to and below the principal axis along minus y-axis are taken as negative. In a spherical mirror, the distance of the object from its pole is called the object distance u. The distance of the image from the pole of the mirror is called the image distance v. You already know that the distance of the principal focus from the pole is called the focal length f. There is a relationship between these three quantities given by the mirror formula, which is expressed as. This formula is valid in all situations for all spherical mirrors for all positions of the object. You must use the new Cartesian sign convention while substituting numerical values for u, v, f and r in the mirror formula for solving problems.